Current harmonic mitigation of model predictive controlled inverter by zero state modulation. Prepared by Ibrahim Ubaid Muhsin, supervised Dr. Muhammad Nataq. Contents. The contents consist of 5 parts: introduction, background, basic and modified, MPC concept and equation, results and discussion, conclusion. Introduction. MPC methods belong to the wide class of predictive or pre-calculation controllers. MPC can be considered as a subclass of predictive control in general. MPC is a wide class of different control algorithms which share the following basic concepts. An MPC uses the system model in order to calculate optimum values for the actuating variable. An MPC calculates the system behavior for a sequence of value for the actuating variable up to a certain prediction horizon. An MPC determines the optimum sequence of value for actuating variable by minimizing so-called cost function or objective function. Advantages. In general, MPC has several advantages over traditional control method. The most important one are control of multi-dimension system. The cost function can be designed according to user needs. Constraints can be considered within the model and in the control design. The control of linear as well as nonlinear system is possible. Disadvantage. In MPC, the switching take action at one instant at the start of the sampling interval. This results a ripple in the controlled parameters, in our case, load current. Prediction horizon limited by one step, especially in multi-level inverter. This is due to the exponential rise of the calculation burden with more than a step of the prediction horizon. Background. To reduce the current ripple, some studies have tested the extended prediction horizon. It has been shown that working with a two-step horizon reduces harmonic distortion but require a large number of calculations at high switching frequency. To reduce amount of calculations with extended prediction horizon, the use of subset of the total available voltage vector has been tested. This approach depends on the forecasted reference current value and add calculation burden. Accordingly, it has been overlooked in this work. Other research added standard modulation techniques to the MPC controllers to reduce current harmonics. The dual intervals for space vector modulation controller have been determined from the result of the cost function of three inverter vectors, two active vectors plus one zero vector. Another study used an MPC controller to determine a reference voltage vector for a grid-connected inverter. The reference vector has been implemented using the basic SVM technique. The proposed paper, however, suggested an alternative approach that is based on merging a simple zero-state modulator to the typical MPC controller. This modulator can redistribute the switching instant symmetrically within the switching interval to avoid the main cause of the current ripple. The advantage of the proposed method is the application of a simple zero-state modulator that is simple to implement compared to other modulation-based MPC methods. Basic and modified MPC concepts and equation. Two-level voltage source inverter. The power circuit of three-phase two-level voltage source inverter shown in figure 1. The two switch of each phase operates in complementary mode to avoid short circuit across the DC voltage source. The voltage vector shown in figure 2 are generated by combining the possible value of states. Basic MPC for two-level voltage source inverter. Figure 3 show a model of the system. The model of the system consists of load inductance, load resistance, and back EMF. The equation can be used to characterize load current dynamic using Kirchhoff law as below. V equal L di by dt plus Ri plus back EMF. A suitable discrete time predicted model using Euler approximation for current is given by basic MPC algorithm. Figure 4 show a flow diagram of various tasks performed by predictive controller. Estimated back EMF, we need counter, predictive current, evaluate cost function, minimize cost function, store optimum value, apply optimum vector. Here, the outer loop is executed every sampling time, and the inner loop is executed for each possible state, obtaining the optimal switching state to be applied during the next sampling period. Modified equation. Equation 3 derived to be equivalent to equation 2 to describe the predicted voltage vector in terms of predicted and measured current value. Thus, the cost function includes the difference between the voltage of the next step described in 3 and the voltage of the inverter vector. Zero state modulation. In predictive control, the switching state that has the voltage vector closest to the predicted voltage vector based on the cost function is selected. Zero state modulation leads to an effective inverter vector closer to the predicted voltage of the next step. Figure 6 shows the three vector and duty ratio is determined as the following equation. Modified MPC algorithm. Figure 7 shows a flow diagram of the various tasks performed by predictive controller. This scheme is similar to the one used in basic MPC algorithm. The difference is by using equations derived from basic equation and adding zero state modulation. Result and discussion. Figure 8 display the THD as a function of the reference current for the basic MPC and the modified MPC at sampling time 100 microsecond. The results show that the inclusion of the zero state leads to reduction of the harmonic distortion of the output current. It was also noted that the difference between the two methods decrease at low reference currents because the zero state is sometimes selected as an optimum state by in the basic MPC. Table 1 shows that the inclusion of zero state increases the switching frequency by up to 22%. It's worth noting that this frequency remains low compared to the linear method used with MPC. Conclusion. This paper presents a modified MPC current controller. based of zero-state modulation. For this purpose, modified MPC control equations have been derived. The inclusion of zero state led to significant improvement in harmonic distortion of the output current. However, this method incurs some increase in the average switching frequency. Finally, this work presents a compromise between the complexity added by MPC with full modulator and the harmonic distortion associated with the basic MPC method by using a simplified zero-state modulation. Thank you for watching.